Hello, I'm Jim Flanagan, and welcome to the International Space Station. This is the third in a series of lessons entitled Math. What's the use? Have you ever been in a discussion with someone and you just can't convince them that you're right? And you think, what do I have to do? Draw you a picture? Well, you don't have to, but it sure would help. Please enjoy. How do you win an argument using math? Let's start with ways to express numbers. Suppose your argument involves very large amounts of money being spent well or poorly. How do you get someone to understand how much $1 million or $1 billion really is? One way is to imagine an activity that anyone can do. Imagine physically counting $1 million, $1 bill per second all day long, 24/7 with no breaks until you're done. So $1 million times 1 second per dollar times 1 minute to 60 seconds times 1 hour to 60 minutes times 1 day divided by 24 hours. So it would take you a little over 11.5 days to count $1 million. Well, $1 billion is about the same, isn't it? It would take you almost 32 years to count $1 billion. Another good way to visualize big numbers is to imagine you won it in the lottery. If you won $1 million in the lottery and enjoyed it by spending $5,000 per day on anything you wanted, then you would have the best 200 days of your life. Now imagine you won $1 billion and you plan to spend it in the same way. How long will it take? That would take over 200,000 days. But that's one of those numbers, it's just too big to comprehend. So what we can do is convert it into years. In that case, it would take you 547 years to spend all that money. Now let's talk about oil spills. How serious are they really? Before we do that, we really should probably take a second to define area versus volume. Area is the measurement of a two-dimensional surface. The formula for the area of a rectangle is width times height. Volume is the amount of space that an object occupies. The formula for volume of a box is width times height times depth. So, oil spills. They aren't very serious, are they? The Deepwater Horizon oil spill in 2010 was and is the largest marine oil spill in history. But how do you show someone how much oil got released into the water? How do you show someone what 134 million gallons of oil looks like? One way might be to imagine filling a really big box full of the spilled oil. So the question is, how big would that box have to be? First, we need to convert the spilled oil into units of volume. 7.481 gallons of a liquid would fill a box that is 1 foot wide, 1 foot high, and 1 foot deep. In other words, a cubic foot. According to the National Oceanographic and Atmospheric Administration, or NOAA, the Deepwater Horizon oil drill rig spilled 134 million gallons of oil into the Gulf of Mexico. That's equivalent to 17,912,043.84 cubic feet. Now let's build the box. Imagine we build the box over a football field. The bottom of the box is the football field itself. The length of a football field is 100 yards or 300 feet. The width of a football field is 160 feet. Now we just have to calculate the height of the box. The formula for volume is width times depth times height. The volume of a box we want to build is found by multiplying 300 feet by 160 feet times the height. So plugging in the volume of the oil into the formula for volume, we get, dividing both sides to get our height alone and canceling out any units that we can, we find the height of the box would have to be 373.2 feet. So in order to hold all that oil, our box is going to have to be more than the length of the football field high. If this is difficult to picture, then how about if we use an activity common to everybody? Imagine taking a shower in all that oil. The standard water flow rate for a shower is 2.5 gallons per minute. So we can find the time it would take to shower in all that oil by multiplying the amount of oil spilled by the ratio of 1 minute per 2.5 gallons. That turns out to be 53,600,000 minutes. If our goal here is to convert difficult ideas into something you can actually visualize, then the number of minutes is just too big a number. Nobody thinks in terms like this. So let's convert that to hours. Still too big. Let's convert that to days. Still too big. Finally, let's convert it to years. So you can see that you would have to shower every day and every hour 24/7 for over 101 years to use up all that oil. Next, let's talk about the Great Pacific Garbage Patch. It's located in the central North Pacific Ocean, and it's a collection of plastic and floating trash that originated from the Pacific Rim, including countries in Asia, North America, and South America. Researchers from the Ocean Cleanup Project estimate that the patch covers 620,000 square miles. If the garbage patch was in the shape of an actual square, that square would need sides measuring over 787 miles, which is still too big a number to wrap your head around. So let's try a circle. The formula for the area of a circle is pi r squared. Substituting in the area of the garbage patch, we get 620,000 square miles equals pi r squared. So if the garbage patch was in the shape of a circle, the radius would have to be 444.24 miles and have a diameter of 888.5 miles. Still, the number's too big. How about if we compare it to something more familiar? 888 miles is about the distance from New York City to Nashville, Tennessee. If you were to get in your car and drive nonstop at 60 miles an hour, it would take you about 14 hours and 48 minutes. And that's how big the Great Pacific Garbage Patch is. Finally, let's talk about styrofoam coffee cups. The United States uses about 120 billion disposable coffee cups annually. Polystyrene foam cups have the reputation of not being recyclable, non-biodegradable, and a major part of marine litter. Let's take a 12-ounce styrofoam cup with a height of 4 inches. If we were to build a tower of all those cups produced in a single year without inserting one into the other, it would reach a height of 7,575,757.57 miles. If the moon is 238,900 miles away, then we could stack those cups from the Earth to the moon, from the moon to the Earth, and back to the moon again. But most people have never traveled from here to the moon, so maybe we can do better. For our last example, then, let's imagine a highway. On the side of the highway, we have taken the tower of cups and laid them along the side of the road. Now let's imagine a car driving up the highway, approaching the beginning of the cup line and reaching and holding a speed of 60 miles per hour at that moment. Now let's imagine that at that exact moment, your mother, who has been in labor for several hours, suddenly gives birth to you. The question is simple. How old would you be when you reach the end of the line of styrofoam cups the United States uses in just 1 year? So it looks like it would take over 14 years of riding in the car to get to the end of the line. And if that doesn't convince someone that we have a problem, then I don't know what will. Here endeth the lesson. Thanks for listening.